Welcome to Fat Math. Long division and synthetic division are two ways in finding the remainder when a polynomial is divided by another polynomial. In this video, I will show you another way of finding the remainder when a polynomial is divided by another polynomial. This is what we call the remainder theorem. So by using the remainder theorem, we can identify the remainder when a polynomial is divided by a polynomial of the form x minus a constant. So find out in this video if this process is the easiest of the three in identifying the remainder. So enjoy learning! Hi everyone, welcome to Fat Math. In this video, we will have the remainder and the factor theorem. So please like and subscribe to support this channel. If you have some questions, you can comment down below. Let's start. The remainder theorem. If a polynomial p of x is divided by x minus a, then the remainder is equal to p of a. Meaning to say, if we are asked for the remainder when a polynomial is divided by a binomial of the form x minus a, where a is a constant, then we just solve for the p of a. Meaning to say, we will replace x with a and solve for the value and evaluate the polynomial. For example, what is the remainder when 3x squared minus 28x plus 32 is divided by x minus 8? Okay, so you can divide this by using the long division or the synthetic division, but since the question is only the remainder, you can just use the remainder theorem. If we use the synthetic division, we will use the coefficients of the variable here. So we have 3, negative 28, and 32. Using synthetic division, we will have 3 times 8, 24, negative 28 plus 24 is negative 4. Negative 4 times times 8 is negative 32 and 0 here. Meaning to say the remainder is 0. So that is if you use synthetic division. But if you use the remainder theorem, the remainder is just p of a, meaning to say we will just replace x here with the value of a. In this case, our a here is 8. So let's just solve for p of 8 because here x minus a. So if it's x minus number here, then this number is the a. So p of a is just p of 8. So replace x with 8. So this is going to be 3x squared. So 3 times 8 squared minus 28 times 8 plus 32. And then you can solve 8 squared first before you multiply. So 8 squared is 64. Negative 28 times 8 is negative 224. Copy plus 32. 3 times 64 is 192, and then copy the others. And then 192 minus 224, that is negative 32, plus 32 is 0. So we get the same remainder. It is 0. So in finding the remainder, if you use the remainder theorem, you just solve for p of a. So it's also 0. So this is the process when you use synthetic division. So you have to look at the last number here in the synthetic division. And if you're using the remainder theorem, then you need to solve for p of a. Let us have another example. What is the remainder when 2x squared plus 3x minus 3 is divided by x plus 3? So if you use synthetic division, you will have the coefficients 2, 3, and negative 3. Divide by our a here is negative 3. So negative 3. Bring down 2. 2 times negative 3 is negative 6. 3 plus negative 6, that's negative 3. Negative 3 times negative 3, that's positive 9. And negative 3 plus 9 is positive 6. So the remainder is 6. If we use the remainder theorem, then we will have p of negative 3. So replace x with negative 3. So you will have 2 times negative 3 squared plus 3 times negative 3 minus 3. Negative 3 squared is 9. So you will have 2 times 9. 3 times negative 3 is negative 9 minus 3. So you will have 18 minus 9 minus 3. That is 9 minus 3, which is 6. So the same remainder. The remainder here is 6. Here it's also 6. So you can use either process, but if we will apply the remainder theorem, this is the process that you're going to use. Third example, find the remainder when x raised to 6 plus 3x squared minus 4 is divided by x plus 1. So what is our a here? That's right, it's negative 1. So here, if we use synthetic division, we have to arrange the powers of x here. So for x raised to 6, the coefficient is 1. For x raised to 5, 0. For x raised to 4, 0. For x raised to 3, 0. For x squared, that's 3. For x, 0. And for the constant, negative 4. So this is the process when you use synthetic division. So divide by negative 1. Bring down 1, negative 1, negative 1. Negative 1 times negative 1, positive 1. That's 1. Then negative 1, negative 1, positive 1. 3 plus 1 is 4. 4 times negative 1 is negative 4. You add negative 4. Negative 4 times negative 1, it's positive 4. And then you add 0. So this is the remainder. So the remainder is 0. So this is the process when you use synthetic division. Okay, so it seems like my process here, or how I discuss this synthetic division, is fast, because I have another video for synthetic division. You can visit Fatma TV and check on division using synthetic division, because there I have many examples, and the discussion there is slow because the focus is on synthetic division. But in this video, our focus is on the remainder and the factor theorem. So if we use the remainder theorem, just solve for p of negative 1. Okay, this should be p of negative 1, because our a here is negative 1. So this has to be negative 1. So as what you can see here, it's already negative 1. Okay, so replace x with negative 1. So we're going to have negative 1 raised to 6. So this one, plus 3 times negative 1 squared for this one, and then copy negative 4. And then negative 1 raised to 6 is positive 1. Negative 1 squared is positive 1. So that's 3 times 1. And then copy negative 4. So 3 times 1 is 3. So 1 plus 3 is 4 minus 4. That is 0. So the answer is 0. So the remainder when x raised to 6 plus 3x squared minus 4 is divided by x plus 1 is 0. Next, example number 4. Find the remainder when x raised to 5 plus 3 is divided by x minus 2. So if this is the question, you have the option to use long division, synthetic division, or the remainder theorem, whichever is the most comfortable for you. But for polynomials with high powers of x, I suggest that you use the remainder theorem, especially if there are other powers of x that are not in the dividend. Okay, so our a here is positive 2. So divide. Okay, bring down 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. 0 plus 8 is 8. 8 times 2 is 16. 0 plus 16 is 16. 16 times 2 is 32. 3 plus 32 is 35. So the remainder is 35. This is when you use the synthetic division, but if you use the remainder theorem, just solve for p of 2. So p of 2, just replace x with 2. So 2 raised to 5 plus 3 So that is equal to 32 plus 3, that is 35. So as what you can see here, the process is just short. But in the previous examples, synthetic division was shorter. So it's up to you what you're going to use. So, whichever process you will use, you will get the same answer. 35 and 35. But if you want just to be sure, you can use two processes and then check if your answers are the same. So the answer here, or the remainder here, is 35. Example number 5. Find the remainder when 3x raised to 4 minus x cubed plus 6x squared minus 5x plus 1 is divided by 3x minus 1. So if we use synthetic division, we will use the coefficient 3, -1, 6, -5, and 1. Divide by, let us divide this first by x minus 1/3. And then divide again later on by 3. Oh, that is if you need to use, or if you need the quotient. But if you only need the remainder, then you just simply solve for p of a. So bring down 3, 3 times 1/3, that's 1, -1 plus 1, 0, 0 times 1/3, 0, 6 plus 0, 6, 6 times 1/3, 2, -5 plus 2 is -3, -3 times 1/3 is -1, 1 plus -1 is 0, so the remainder is 0. If we use the remainder theorem, we will have p of 1/3. So 3 times 1/3 raised to 4 minus 1/3 cubed plus 6 times 1/3 squared minus 5 times 1/3 plus 1. A little bit longer. 1/3 raised to 4 is 1/3 times 1/3 times 1/3 times 1/3. That's 1 over 81 minus, this is 1 over 27 plus 6 times 1/9 minus 5/3 plus 1. So 3 times 1 over 81, we can cancel 3. So we will have 27, 1 over 27 minus 1 over 27. And then 6 times 1/9, we can divide this by 3. We will get 2. Divide this by 3, we will get 3. So we will have 2/3 minus 5/3. And then 1, we will just write it as 3/3 so that they will have the same denominator here. So 1/27 minus 1/27, this is going to be 0. This is 0. And then 2/3 minus 5/3 is -3/3. -3/3 plus 3/3 is 0 over 3, or that is 0. So in this case, I think synthetic division is easier to use to find the remainder. But if you want to use the remainder theorem, this is the process. So this includes fractions. Okay, so that's it for the remainder theorem. So the remainder theorem is just a shortcut to find the remainder. A shortcut if for a given that have higher powers of x and the other powers are not there. So it's easy to solve for the value of p of a. But sometimes synthetic division is also shorter. What does the factor theorem say? The factor theorem says that x minus a is a factor of a polynomial p of x if and only if p of a is equal to 0. Meaning to say, x minus a is a factor if the remainder is 0, or the other way around. If the remainder is 0 when p of x is divided by x minus a, when the remainder is 0, then x minus a is a factor of p of x. So that is an if and only if statement. If p, then q, and if q, then p. So that is in logic. Okay, so for the examples that we solved in earlier in this video, we have the following. We divided 3x squared minus 28x plus 32 by x minus 8. And we found out that the remainder is 0. So x minus 8 is a factor of the dividend. Here the remainder is 6. So x plus 3 is not a factor of the dividend. Here x plus 1. The remainder is 0, so x plus 1 is a factor of the dividend. And then in the fourth example, our remainder is 35. So the divisor is not a factor of the dividend. And number 5, the remainder is 0. Therefore, 3x minus 1 is a factor of the dividend. So the factor theorem says that if the remainder is 0, then the divisor is a factor. Okay, so you can have this as your practice. So you can pause the video if you need more time to answer this. So you can use your bond paper there, or your intermediate pad, or your ball pen and your yellow paper there if you want to practice on these items. So we have here 5 items, and you can pause this video. So don't forget to like and subscribe Fat Math, and I hope that you are also watching the other videos. There are more contents for grade 10 mathematics here. There are also others in pre-calculus and basic calculus and general mathematics. Hopefully later on, we will complete the contents of the different mathematics subjects in high school. Okay, so pause this video if you're not yet ready, because I will reveal the answers. So here are the answers. Number 1, the remainder is 0, so x plus 2 is a factor. Number 2, the remainder is 110, so x minus 5 is not a factor. Number 3, x minus 1 is a factor because the remainder when divided is 0. And then number 4, x plus 2 is not a factor because the remainder is going to be 8. And number 5, negative 3 is the remainder, so 2x plus 3 is not a factor of 8x cubed minus 4x squared minus 10x minus 6. So comment down below if you got 5. Congratulations. I hope that you learned in this video. Continue to support FatMath TV. So that's all for this video. Thank you and goodbye. Thank you for watching this video. Don't forget to like and subscribe FatMath. Bye!